Good day, everybody. Today I want to talk about symmetry, but first I want to acknowledge Dr. X is back here along with Ant-Man. You're welcome. And I'm repping Augsburg because one of those came from Augsburg. That one came from Augsburg. Okay, so let's talk about symmetry and about intercepts. But first we're going to talk about symmetry in graphs, okay? Now, mathematics is a language. It's a language of symbology. The symbols come in number and letter form about the ideas of our entire world. They also come in graphs. And this came about because of Rene Descartes. And because of Descartes having this new branch of mathematics, Cartesian coordinates, where it changed cartography, it changed mapping, okay? According to lore, Rene Descartes was not feeling well during the plague or sometime, and he's out in the countryside watching a fly go across the ceiling on square ceiling tiles. And he's pondering to himself, if I were to write a letter to my friend somewhere far away, could I describe to him how the fly is moving without him being here? So he was like, well, I could say it was at that intersection, and then it went over to that intersection. Lo and behold, the invention of the coordinate plane, which utterly changed mapping, was born. It's like, let's put a grid on the world. Okay? So that's the reason why you learn this. Facts. And the grid on the world that now we call data, okay? Exponential growth, exponential decay, sine, cosine, tangent, right? Going along in the world, and all these words we came up with for it, is a way to communicate. It communicates the past so that we can project into the future. You are learning essentially the ABCs of graphing. Okay? So we're like doing A, B, C, D, but with graphs. Okay? We're not writing poetry yet. So let's talk about symmetry. Okay? Now, in order to know symmetry, you have to know I've got a bunch of stuff here. You have to know what your things are, okay? So I want you to know the Greeks, they all learned, all those people that we talk about being so insanely intelligent, you know how they learned? With sand in the ground, and then they'd use their finger and they'd draw these things and they'd communicate. So I appreciate this technology. Technology is allowing us to talk this way, but the reality is, me and my whiteboard and I have a dream, and we're coming for you. So I don't need the fancy things. I want you to be able to play along. So let's remind ourselves, I've got a couple little graphs here. This is our coordinate plane, okay? This is a sentence maker, okay? And it has structure, capitalize the first letter, put a period at the end, exclamation point, question mark, but it ends somewhere, right? So Y and X. X is the horizontal, Y is the vertical, okay? I know you should know this if you're watching this video, but if you don't, there you go. And P.S., you always put the arrow and the letter on the positive side. That's a little something that mathematicians won't tell you. You don't actually have to eventually put the arrows, okay? I don't know why. You put the arrow with the positive. You always label X and Y that way. This is the coding, which maybe your teacher didn't know to tell you, but that's the facts. Okay, so symmetry is a reflection. I've got a symmetry right now, okay, in the sense that all of this, from my perspective, is backwards. And I'm trusting all the fancy devices that by the time it hits your eyes, it's the right way up, okay? That's a symmetry. Looking in the mirror is a symmetry, okay? So when we say symmetry with respect to the x-axis, what you're saying is that it is a reflection over x. So if this is the point 4, 2, you literally bounce down there. And what is that point? It's 4, negative 2. Okay? Now, which sign actually changed? I know my handwriting's not perfect, but the 4 stayed the same. Remember when we talk about coordinate pairs, it's always x, y. So let's think about this. The reflection or the symmetry around the x-axis changed the y value. to being the inverse. Okay, so reflection on x changes y. Shocker of all shocks, the reflection on y changes, you guessed it, x. 2, 3, 4, 2. So now we're over here, -4, 2. Okay, that's symmetry. All right, now if you're in Algebra 2 trig or pre-calc, you are asked to graph a little faster, right, than linear algebra than algebra students. That's how we do it, okay? So when you reflect about y, you've inverted the x. When you reflect about x, you've inverted the y. Okay, are you with me? Now let's look at this fancy example. Everything's freezing up on me. Okay, which is the symmetry of x or y? Well, the reflection is happening here, so that's a reflection around y, right? And all the x values have changed. Okay, what is this a symmetry of? It's a trick question we haven't talked about yet. This is a symmetry of the line x equals y, okay? This is a diagonal symmetry, okay? I just kind of sketched in, this is the line x equals y. It's a diagonal symmetry, which has a 180-degree rotation. And what you do there is actually you've reflected it about x, and you've reflected it about y, okay? Shock of all shocks, that inverts both parts, okay? So when you look at an equation, and you go, does this have symmetry, right? You can put in the negative, and if it comes out to be true, the answer is yes. So let's do a quick example that I wasn't planning on, but a parabola, okay? If you are in, again, Algebra 2 or Algebra 2 trig pre-calc, these should be a little easier for you to jump in on, right? A parabola, okay? If I put negative x in for this, the square inverts it and turns it right back into this, right? That's the symmetry about that axis, which would be y. Now, if you invert y, it's not the same equation. Okay, that's how you can test it. That's a test of symmetry without having to do the equation. Desmos.com. I am not getting paid by them. Desmos. They are just an incredible graphing utility that I wish existed when I was your age. I had to do all this on my own. Yeah, it can get challenging. Okay, so we said we were going to talk about symmetry and about intercepts. I'm just erasing this a little bit. So intercept. If we're talking about football, right? That means the pass is going from one teammate to another, and the opposite team intercepts the football, okay? So when we use it in mathematics, to intercept is to cross over the axis, okay? Ships across the ocean. Ships across the ocean. So, the intercept is where it crosses, okay? Now, we're not going to be doing this about graphs, though. We're going to be doing it about equations. Okay, I don't know what this is. So here we've got x and y implicit because of the arrows, and I've got my squiggle. This is a function of something. I don't know what it is. But this is the x-intercept, and this is the y-intercept. Okay? Now we talk about this in the y-intercept gets a lot of press in Algebra 1. Right? That's our first instance. And so I think a lot of young people don't realize that. And it's not until you get to trig where you realize, like, oh, this is happening over and over and over. So how do you come up with intercepts with just the equation? Well, let's look at our weird little picture again. Okay? When I have the x-intercept, I'm on the x-axis. What is the value of y? Okay. All of y up here is positive values. All of y down here are negative values. Okay? The same goes for x. Everything you do on the coordinate plane essentially has to be done twice, because x and y are two separate calculations. This has to be drummed into your head. Okay? But so when you're on the axis, what is the value of y? It's 0. Similarly, when you're on the y-axis, what is the value of x? It's so the test that you do for the intercepts is you set the equations to be zeros. Now, finding the y-intercept is typically easier than finding the x because of the fact that we set up our equation saying y equals blah, right? Function of x equals. Function of x is the same as y, okay? F of x equals y. It's the same as y. So finding the y-intercepts is traditionally a little easier because x goes to nothing, okay? And in most equations, the way we have it set up, there's only one y-intercept. It's just the way we did it. But there can be a multitude of x. And when there is more than one y, it becomes confusing for people. Let's try one example before we are completely gone. Moving on, okay? Give me a moment. I'm going to find my example before I erase it. Okay. Let's see. Y equals, and I'm going to erase this. Okay. Y equals x squared minus 4 over x squared plus 1. Okay. Now, when x is 0, this is rather easy. 0 squared minus 4 over 0 squared plus 1 is negative 4 over 1, which is negative 4. That is the y-intercept. When x is 0, y is negative 4. Okay? Slightly harder one is when y is 0, what is x? Okay? Now, we have to talk about, we'll talk about this later, but we can multiply both sides by x squared plus 1, so we get this, that. Then we have to factor. Those are the difference of squares. We'll talk about this another time. If you have a question, please drop it in the thing. Okay? So we get that x equals 2, x equals negative 2. So we have, these are our intercepts. 2, 0, negative 2, 0, and 0, negative 4. So I know my equation has those 3 spots. Just do. I know I went over that example quickly, but because this is meant to be an overview, and if you have a specific question, I can show it to you. There's always a lot to go on. But the larger ideas, okay, of what you're being asked to do is you are being asked to, can I take this equation and know what it looks like? Okay? Desmos.com is really great. I cannot express it enough. Desmos.com. I'm not getting paid for any of this, but this is just a fundamentally phenomenal resource. Okay? Put your equation into that site. It'll graph it for you. You can analyze what's going on. I'm telling you what the analysis is that you're looking for. This is why I'm not doing a lot of how-to examples. I do some of them because I know that these things exist with technology. The problem for a lot of young people right now is that there's a disconnect between, well, okay, there's this thing, but I don't know what that means to me, right? That's where I come in. So, thank you for watching. If you made it this far, I appreciate you. I can always use the subscribe and like. Just because I'm trying to build this, I'm just giving away lessons for free. I want young people to understand how to do math. I want their parents to. I want the whole world to understand the whole world. And math is a gigantic part of it. If you like, share, subscribe, it just helps more people find it. Okay? I'm not getting paid. And if I ever did get paid, I more than likely would give it to all the nonprofits that I know that are helping children, okay? We've got a lot of problems in our world. I just want to be part of the solution. So if you have questions, please feel free to let me know. Thank you so much. Have a beautiful, beautiful day. Misty out.